Namaste students, welcome back to Sumanth tutorial. In this session, I'm going to deal with the entire content about resistance. In that, we are going to deal with the resistance along with the resistivity and combination of resistors. What are the tricks you need to solve with the numerical as well as the content related to the board exam? The entire thing I'm going to discuss with you. Once again, we are going to follow the same thing. Keep a book and pen ready with you. I'm gonna say all the tricks, you just note down. You can pause it and then also you can write, it doesn't matter. Okay, let us do not waste our time. Let's start with the session. See, directly I'm gonna take with the resistance. Yeah, so what is resistance? Resistance is a process which controls the flow of charges. That's it. And you know, ಒಂದು ವೈರಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪಾಸ್ ಆಗ್ತದೆ, ಚಾರ್ಜಸ್ ಪಾಸ್ ಆಗ್ತದೆ. ಐ ವಾಂಟ್ ಟು ಕಂಟ್ರೋಲ್ ಇಟ್. ಓನ್ಲಿ ಅ ಪಾರ್ಟ್ ಆಫ್ ಕರೆಂಟ್ ಶುಡ್ ಮೂವ್ ಔಟ್. ಸೊ ಆ ಪ್ರೋಸೆಸ್ನ ಏನಂತ ಕರಿತೀವಿ? ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಐ ರಿಪೀಟ್ ಒನ್ ಮೋರ್ ಟೈಮ್. ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಎ ಪ್ರೋಸೆಸ್ ವಿಚ್ ಕಂಟ್ರೋಲ್ಸ್ ದ ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜಸ್ and the device is called as a resistor. And the device is called as a resistor. The symbolic representation of a resistor, this is the symbolic representation. And the SI unit of resistance is ohm. So what is the SI unit of resistance? SI unit of resistance is ohm. How to represent? This is the symbolic representation of a ohm. Done? Clear? So I repeat one more time. Resistance is a process which controls the flow of charges, and the device is resistor, and the SI unit of resistance is ohm, and this is the symbol. That's it. Then the factors affecting the resistance of a wire. The factors which is affecting the resistance of the wire. The first one is length. See, resistance directly proportional to the length of a wire. So what are the things I'm gonna write here? It's important. Please make a note. So what it says? It says very clearly, if the length of a wire is increasing 1 meter, 2 meter, 3 meter, like that. If the length of a wire is increasing, then the resistance value will also increase. That's why the resistance directly proportional to the length of a conductor. Next, the resistance directly proportional to the temperature. Let me mark here like this. Directly proportional to temperature. Like length. If the temperature of a conductor is increasing, then the resistance of the wire will also increase. That's it. And then you know, temperature 30 degree, 40 degree, 50 degree, the temperature rise ಆಗ್ತಾ ಇದೆ. ಸೊ ಅದ್ರ ತಕ್ಕಂತೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದ ವೈರ್ ಏನಾಗುತ್ತೆ? ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದ ವೈರ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Next, the third one. This resistance inversely proportional to the area of cross section. Area of cross section ಅಂದಾಗ ಮೈಂಡ್ ಅಲ್ಲಿ ಸೆಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, thickness of the wire. That's it. If the thickness of the wire is increasing, the resistance decreases. That's the reason it is inversely proportional. How to remember? Compare this one with the pipe and water. So if the pipe is bigger one, flow of water will be maximum. ಹೌದಾ? ಪೈಪ್ ದೊಡ್ಡದಾದಷ್ಟು ನೀರು ಜಾಸ್ತಿ ಫ್ಲೋ ಆಗುತ್ತೆ, ಪೈಪ್ ಕಮ್ಮಿ ಇದ್ದಷ್ಟು ನೀರು ಕಮ್ಮಿ ಫ್ಲೋ ಆಗುತ್ತೆ. ಡೋಂಟ್ ರೈಟ್ ದಿಸ್ ಒನ್ ಇನ್ ಎಕ್ಸಾಮಲ್ಲಿ ಇದೆಲ್ಲ ಬರೀಬಾರ್ದು. ಜಸ್ಟ್ ಫಾರ್ ಯುವರ್ ನಾಲೆಡ್ಜ್, ಮೀನ್ಸ್ ಇಟ್ಸ್ ವೆರಿ ಕ್ಲಿಯರ್. ಇಫ್ ದ ಥಿಕ್ನೆಸ್ ಆಫ್ ದ ವೈರ್ ಇಸ್ ಮೋರ್, ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಲೆಸ್. ವೈರ್ ಸಣ್ಣದಿಂದ ದಪ್ಪ ತಗೊಂಡು ಹೋಗ್ತಾ ಇದ್ದೀನಿ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗ್ತಾ ಇದೆ? ಕಮ್ಮಿ ಆಗ್ತಾ ಬರ್ತಾ ಇದೆ. ದಟ್ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಸಿ ಹಿಯರ್, these three most important. Then the final one, it depends on material. Which material that we are going to use it. ಅದರ ಮೇಲೂ ಕೂಡ ರೆಸಿಸ್ಟೆನ್ಸ್ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಮೀನ್ಸ್ ಇಫ್ ಸಮ್ವನ್ ಆಸ್ಕ್ ಯು ದ ಕ್ವಶನ್ ವಿಚ್ ಇಸ್ ದ ಬೆಸ್ಟ್ ಮೆಟಲ್ ಫಾರ್ ಕಂಡಕ್ಟಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಅಂದ್ರೆ ಆನ್ಸರ್ ಇಸ್ ವೆರಿ ಸಿಂಪಲ್. ಇಟ್ ಇಸ್ ಸಿಲ್ವರ್. Silver is the best material or the best metal to conduct electricity. Silver is the best material. But we will not use silver for wiring. Silver ಅನ್ನು ನಾವು ವೈರಿಂಗಿಗೆ ಯೂಸ್ ಮಾಡಲ್ಲ ನಾವು. Why? Because it is costly. It is so costly, so we won't use it. Just imagine the electric wire is made up of silver. What we have to, we would have cut the wire and take to our home. ಹೌದಲ್ಲ? ಸೊ ಸಿಲ್ವರ್ ತುಂಬಾ ಕಾಸ್ಟ್ಲಿ ಇದೆ. ಸೊ ಸಿಲ್ವರ್ ವೈರ್ ಏನಾದ್ರು ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ನಾವು ಏನ್ ಮಾಡಕ್ಕಾಗುತ್ತೆ? ಸಿಲ್ವರ್ ವೈರ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಕಟ್ ಮಾಡ್ಕೊಂಡು ಮನೆಗೆ ತಗೊಂಡು ಹೋಗ್ಬಿಡ್ತಾರೆ. ಹೌದಲ್ಲ? ಹಾಗಾಗಿ ವಿ ವಾಂಟ್ ಯೂಸ್ ಸಿಲ್ವರ್ ಬಿಕಾಸ್ ಆಫ್ cost. It is too much costly. That's the reason we depends on copper or aluminum. Copper or aluminum ಗೆ ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ತೇವೆ. So if someone has in an examination paper, so which is the best metal for conducting electricity, ಅಂದಾಗ please write silver, don't write copper. I know maximum students will write the copper only because we had seen copper, we had never seen any silver wire. ಹೌದಲ್ವಾ? ವಿ ಆರ್ ನಾಟ್ ಕಿಂಗ್ಸ್ ಅಂಡ್ ಕ್ವೀನ್ಸ್. ಹೌದಲ್ಲ? ಮನೆಯಲ್ಲಿ ಎಲ್ಲ ವೈರಿಂಗು ಸಿಲ್ವರ್ ಅಲ್ಲಿ ಮಾಡೋಕ್ಕೆ ನೋ. ಸೊ ವಿ ಆರ್ ಗೋನ್ ಯೂಸ್ ಕಾಪರ್ ಅಂಡ್ ಅಲ್ಯೂಮಿನಿಯಂ ಆಸ್ ಇಟ್ ಈಸ್ ಲೆಸ್ ಕಾಸ್ಟ್ ಕಂಪೇರ್ಡ್ ಟು ದಟ್ ಆಫ್ ಸಿಲ್ವರ್. ಐ ಥಿಂಕ್ ಕಂಟೆಂಟ್ ಇಸ್ ಕ್ಲಿಯರ್. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಸಿ ಬೋರ್ಡಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ. ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಐ ರಿಪೀಟ್ ದ ಕಂಟೆಂಟ್. ಸೊ ದಿಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಲೆಂತ್. Resistance directly depends on the temperature, and the resistance is inversely proportional to area of cross section, and also it depends on material. Sure. Then if I draw a graph here, potential versus the current, I will get a straight line passing through the origin, and here the slope. Once again the same story. I am going to construct a slope here. Slope and y-axis by x-axis. So here, if I name here A, B and a C, then the slope is AB by BC. How that? It's y coordinate by x coordinate or y-axis by x-axis. Here y-axis is potential, and current is taken in the x-axis, and this slope will going to give the value of, very good, it is resistance. That is R is equal to V by I. On which basis I wrote? This is from which law? That is Ohm's law. Very good. So Ohm's law, I have already done a good video, around 1 hour video regarding this law only. Just go through with that content. So Ohm's law says V is equal to IR. From this I got R is equal to V by I. Sure. Here this is important. So this is the entire content about resistance. Then clear? Sure. Note ಮಾಡ್ಕೊಂಡ್ರಾ? This is important one. So I think you have cleared the content. Let me clear the board. If you have cleared the content, I will clear the board. Then, okay. Let me erase. Okay, fine. This clears now. Let me wipe one more time. Yeah. So resistance concept I cleared. Next, what I said we are going to deal with one more, that is called resistivity. Or the other name for the resistivity is a specific resistance. There are two names for it. One is resistivity. Other name is specific resistance. Name ಹೇಳ್ತಾ ಇದೆಯಲ್ಲ, the name itself it is telling. We are finding a resistance with some specific thing. What is that? Length. That's it. So how to define specific resistance? It is the resistance of a wire per unit length. That's it. Per unit length, ಒಂದು ಲೆಂತ್ಗೆ ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ತಗೊಳ್ತೀವೋ ಅದನ್ನು ನಾವು ಸ್ಪೆಸಿಫಿಕ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. That's it. Nothing special. I repeat one more time. What is resistivity or the specific resistance? It is the resistance of a wire per unit length. ಅಂದರೆ ನನ್ನ ಹತ್ರ 1000 ಮೀಟರ್ ಆಫ್ ವೈರ್ ಇದೆ, ಆದರೆ 1 meter ಅಲ್ಲಿ ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದೆಯೋ that is the specific resistance. That's it. ಹಾಗಾದ್ರೆ with respect to the definition I can easily write the SI unit. So its SI unit is ohm meter. That's it. Ohm resistance, m meter. So specific resistance SI unit is ohm meter. That's it. I repeat one more time. SI unit of specific resistance is ohm meter. Now let's go to the formula one. Formula is most important. Now see here, R is equal to rho L by A is the standard formula. This is the standard formula. So here, what does this R represents? Resistance. R representing resistance. L, we know very clearly, it is length. A, area of the cross section. Then what is this symbol? This symbol is rho, that is resistivity. ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೋತೀನಿ. ಹೌದಾ ಸರ್? ಏನು ಸರ್ ರೆಸಿಸ್ಟಿವಿಟಿ ಅಂತ ಹೆಡ್ಡಿಂಗ್ ಹಾಕಿದ್ದೀರಾ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಫಾರ್ಮುಲಾ ಬರೆದಿದ್ದೀರಾ ಅಂತ ಕನ್ಫ್ಯೂಷನ್ ಆಗಬೇಡಿ. ಸೊ ವೈ ಹ್ಯಾವ್ ಸೆಲೆಕ್ಟೆಡ್ ದಿಸ್ ಫಾರ್ಮುಲಾ? ದಿಸ್ ಇಸ್ ದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮುಲಾ. Here we can extract resistivity. ಹೌದಲ್ಲ? ಹಾಗಾದ್ರೆ resistivity ಏನಾಗುತ್ತೆ? Resistivity will be equal to R into A by L ಅಷ್ಟೇ. ತುಂಬಾ ಫಾರ್ಮುಲಾ ಆದಾಗ you will get confused. So if multiple formulas if I give, it becomes very difficult for you to analyze. So learn a standard formula. Transpose will be done afterwards. Done? So I repeat one more time. This formula is important. Resistivity R is equal to rho L by A. Can you see this symbol? Ulta name. This row. This is resistivity. Done? Clear? Now, here also factors. Factors affecting. Factors affecting the resistance. Or the specific resistance here. The first one is material. Material is important. Now, if I want to group it on which material this resistivity or the specific resistance depends, andre I will divide under 3 categories. Which are the 3 categories? First is metal or alloy. Metal or alloy. Second one is semiconductors. Semiconductors. And the last one is insulators. Then there are 3 types in a material: metal or alloy. Second one is semiconductor. Third one is insulator. See here, for metal, this specific resistance is 2 least. S2 10 to the power minus 8 ohm meter. Too low. 10 to the power minus 8. Then for semiconductor it is low. 10 power minus 5 ohm meter. But for insulator it is max. 10 to the power 13 ohm meter. Means by observing these numbers, you can easily decide for metals, the specific resistance is too much least. For semiconductors, it is more, and for insulator, it is max. So if I write like this, metals, okay, then another one is semiconductors, another one is insulators. For insulators, it is maximum, then the semiconductors, then the metals. These numbers, it will be different with sometimes with the different textbooks. Once you please check what will be the value. Done? Okay. Now, second one, temperature. Temperature, how it affects on temperature. See here also 3 groups we will make. So first one is metals, another one is the semiconductors, another one will make it as alloys. Okay, see here, for metals, sorry, now see here, as the second factor I have selected its temperature. For metals it is directly proportional. So how to write? I will write here, if the temperature increases in metal, then resistivity will also increase. So it is directly proportional. For some semiconductors, it is inversely proportional. If temperature increases, then resistivity decreases. Please make a note. For a metal, if the temperature increases, then resistivity increases. For semiconductors, if the temperature increases, then resistivity decreases. ಎರಡು note ಮಾಡ್ಕೊಂಡ್ರಾ? Metals get directly proportional, semiconductors get inversely proportional. Now the last one, alloys. For few alloys like Constantine and manganese. These two are most important. Why I specified here? It's important. See here, for few alloys like Constantine and manganese, if there is a change in temperature, the resistivity remains constant. There is no change in a value of a resistivity if there is a change in temperature in alloys. Which are those two alloys? Constantine or manganese. So this is the important one. This is the most important. I repeat one more time. All the three I will repeat one more time. If you consider metals for alloy, okay, if you consider metals or alloy, it is too much least 10 to the power minus 8. If you are considering semiconductor, it is least 10 to the power minus 5. For if you are considering alloy, it is the max. It is max resistivity. Then when it is go for the temperature, metals directly proportional, semiconductors inversely proportional, and some alloys like Constantine or manganese, this remains unchanged if there is change in temperature. This is clear. Now, if I am telling on which factor it depends, I should also say which factor it does not depends. See here, the value of resistivity does not depends on its shape or size or length. Please note this one. See, if you double the length of a wire, if you increase the thickness of the wire, or if you change the shape of the wire, its resistivity will not change. Keep this one in your mind. Clear? Is that clear? So it depends only on the material which we have selected, and it affects on metal, semiconductor, insulators or alloys like this. Sure. I think the maximum point you may expect in a board exam, I had written here on the board. Pakana. Clear up? Okay. Note down. Now see here. ಇಷ್ಟೊತ್ತರೆಗೆ ಹೇಳ್ಕೊಟ್ಟಿದ್ದ ಕಂಟೆಂಟ್ ಮೇಲೆ ಕಾನ್ಸೆಪ್ಟ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಲರ್ನ್ಡ್ ಟಿಲ್ ನೌ. The most important numerical you may expect in a board exam, and the easy trick to solve it, those things I am going to teach. Before that, let me write the formula. R is equal to rho L. Rho I will write properly. Wait, it is slippery. Yeah, now it is clear. R is equal to rho L by A. Remember this formula, you should not forget. That's an important one. See, the questions will be like this. If the length of a wire is doubled from its original length, how the new resistance will gonna affect, as well as how a resistivity affect. These are the questions most important. What I said now, I will repeat. If we change the length of a wire, that may be stretched or that may be folded, how the new resistance, or what will be the value of the new resistance, or how the resistivity affects. ಈ ತರ ಕ್ವಶನ್ಸ್ ಗಳು ಬರ್ತಾ ಹೋಗುತ್ತೆ. Then how to solve, one trick I will gonna say. Follow it. Very simple. What the trick says. Trick number 1. So if length doubles, if the length doubles, then the corresponding area will be half times it reduces. If the length doubles, that much of area will gonna reduce. It's very simple. See here, this is the wire, right? This is the wire. If I stretch it to double, if I stretch this one to double, length becomes 2, right? Then what about this area of cross section? It reduces. How much it reduces? How much I will stretch, that much it will reduce. For example, if the length is 3 times more, then area reduces by 3 times. Now the second one, if length is half, then area will be double. If length is half, area will be double. Ulta. That's it. So if length is half, area will be double. Done. So this 2, please make a note. Here I had written 2, that may be 3, 4, 5, 6. How much time it changes? That much of area will gonna change. If it is multiplication by the length, that much of area will gonna reduce. If it is divided by something, that much of area will gonna increase. So this trick you remember. Then how you can expect the question? Question will be like this. Wire of resistance 1 ohm. What is the wire of resistance? The wire of resistance 1 ohm. It's double its length. If the length changes to 2 times, what will be the new resistance? The question will be asked. See, answer is very simple. Now see here, R is equal to rho L by A is the formula. Right? Now here, this is the trick. If length doubles, then area reduces by 2 times. I taught you. Then apply the same thing here. Now rho as it is, length becomes 2L, corresponding A becomes A by 2. Right? Now we know it very clearly, this 2 will go up. Then this becomes rho L by A as it is. This is 2 into 2. This 2 will go to the numerator. Then see here, it is 4 times rho L by A. Right? Now see here, what is this rho L by A? See here, this rho L by A is R. Then can I write it as 4 times R? Right? What's the value of R is given? 1 ohm. So your answer is 4 into 1, which is equal to 4 ohm. See, very easy to score 2 marks. Right? Follow the trick. If you follow this trick, that's enough. This is one type of question. Now, second type of question I will say. See here, if the resistance of the wire is 3 ohm, the resistance of the wire is 3 ohm, then it has tripled on itself. Tripled on itself. Then what will be the new resistance? See here, tripled on itself means L becomes L by 3, corresponding A becomes 3 times E. Tripled on itself. Tripled on itself means folding. Folding one over other. 3 times I am folding. Then length reduces, thickness increases. Very simple concept. So like this I have used. Now use the same formula. R is equal to rho L by A. Now see here. Rho as it is. In place of L, write L by 3. And this A as 3 times A. Right? Now see here. Rho L as it is divided by 3 into 3A. Nothing but rho L by A of 1 by 9. Right? Now see here. What is rho L by A? Once again R. Can I write it as R by 9? What's the value of R is given? 3 ohm. So substitute. It is 3 by 9. Nothing but 1 by 3 ohm. The new resistance will be 1/3 of the original. That's it. Right? Isn't it easy? How it became easy? If you know this trick, If you know this trick, then this becomes very much easy. This is the most important thing that you have to remember. Done? I think you people have noted down. Sure, Paka? Very good. Copy that. Yes. Students, I think you are clear with the content called as resistance and resistivity. ಎರಡು ಕೂಡ ಕಾನ್ಸೆಪ್ಟ್ ಕ್ಲಿಯರ್ ಆಯಿತು ಅಂತ ಅನ್ಕೋತೀನಿ. ಇಫ್ ಯು ಆರ್ ವೆರಿ ಮಚ್ ಕ್ಲಿಯರ್ ವಿತ್ ದ ಕಂಟೆಂಟ್, ನೆಕ್ಸ್ಟ್ ವಿ ವಿಲ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್, that is combination of resistors. This is combination of resistors. So what do you mean by a combination of resistors? So it is very much simple. We know it very clearly. Everybody had seen a circuit in that. If you see a resistor component, it will be more than one, isn't it? So one resistors we won't use it will be more than one. Then how we need to connect? That's an important one. That is a combination of resistors. See here, when it is dealing with a combination of resistors, there are two ways we are going to connect the resistors. So one is series, another one is parallel. So there are two ways we are going to connect our resistors. So one is series combination, another one is parallel combination. So let me deal with the series first. I will explain the entire concept of the series one. Next, we will go to the parallel combination. Then how to connect the series and all, what are the things comes in between, or what are the things will be there in a series, that we are going to discuss now. See here, first let me draw the diagram. See, if we connect resistors like this, end to end, if we connect resistors like this end to end, this type of set we call it as series connection. How many resistors I have taken here? I have taken here 3 resistors. So let me name it R1, R2, R3. If I name R1, R2, R3, there are 3 resistors connected in series. Then how to calculate the value of total resistors connected in a series will be equal to the sum of individual resistors. That's it, very simple. So here, if I want to calculate what is the total resistance in the circuit, I should just sum it. That's it. Imagine the value of the resistor is 1 ohm, 5 ohm and the 6 ohm. Then what is the total resistance in the circuit? It is 1 plus 5 plus 6, so it is 12 ohm. That's it. Clear? That's it. If you want to calculate the total resistance connected in a series, it will be equal to the sum of individual resistance. This basic is clear. Now we will go to a bit extreme one. Now see here, if the resistors are connected in series, then the current in the circuit, let me write the words only, the current in the circuit remains same. Please make a note, very important. If the resistors are connected in a series, the current in the circuit remains constant, then the variable factor is potential. Potential varies. The variable concept is potential. See here, if I consider this one as a diagram, here V1, V2, V3 means it's very clear. For individual component, the potential will be varying, whereas the current in the circuit remains constant. This is sure. I repeat one more time. If resistors are connected in series, current in the circuit is constant, whereas variable factor is potential. Then clear, note down. This is the concept about the series. That's it. Clear? Can I clear the board? Fine. Let me clear it. Fine. Now, I'm gonna explain the next part, that is parallel. Yeah, what happens in a parallel circuit, how we need to connect, how to calculate the value, those things I'm going to deal here. Same thing, just like a series, I'm going to teach parallel one. First diagram, if we connect resistors like this, one below the other, this combination is called as parallel combination, right? So here also I have selected three resistors. So let me name here R1, R2 and R3. How R1, R2, R3 are connected? They are connected in parallel. Done? Then how to calculate the total resistance of it? See here, resistance connected in parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. How these resistors we can calculate? We can calculate the total resistance of the circuit by summing its reciprocal. So 1 by Rp will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, with an example, we are going to deal it. Now see here, consider this one as 2 ohm, this one as 4 ohm and this one as around 5 ohm. 2, 4 and 5. Clear? Now see here, how to calculate the total resistance of it? See here, it is 1 by 2 plus 1 by 4 plus 1 by 5. Right? Now what is the LCM of 5, 4 and 2? 20 is the LCM. Right? 20 is the LCM. So 2 table 10s are, 2 table 10s are, 4 table 5s are, 5 table 4s are. That's it. Very simple. 20 is the LCM. 2 10s are 20, 4 5s are 20, 5 4s are 20. That's it. Then what is the sum? 5 plus 4, sorry, 10, 5 plus 4 is 9, 9 plus 10 is 19 by 20. This is 1 by Rp. But what we have to calculate? We have to calculate Rp, right? Then Rp is 20 by 19. Then, so this is how, after dividing, what the answer you will get, that much of ohm is there that you calculate. But observe one thing. If you connect resistors in parallel, the total resistance will be less. If you connect resistance in a series, the total resistance will be high. So this is the basic construction, how we are going to calculate it. Now see here, if there are only two resistors connected, if there are only two resistors connected in a parallel, so how to calculate the total resistance? If it is R1 and R2, imagine this is 6 ohm and imagine this is 4 ohm. Then what's the total resistance in the circuit? I will say in a simplest way. You can solve like 1 by Rp is 1 by R1 plus 1 by R2 substitution and doing the solution. That is, you will get an answer. There is one more easiest way. That is, Rp will be equal to R1 R2 divided by R1 plus R2. Same as this one only. After calculation, you will get this. Here, observe. No need to take the reciprocal of the finals. It will be direct. Then what is the solution here? See here, 6 into 4 divided by 6 plus 4. So it is 24 by 10 and your answer is 2.4 ohm. That's it. See how easy we got? Hodala. 6 4s are 24 divided by 6 plus 4 is 10. So the answer is 2.4 ohm. So this is how we are going to calculate the resistors when it is connected in parallel. Make a note, you are going to use this form when only two resistors are connected in parallel. More than two, you have to use this method only. Clear? Now, next thing is, as I said, we are going to compare like a series along with the parallel. Here also we are going to consider which is constant and which is variable. Now see here. In a parallel circuit, current varies. In a parallel circuit, current varies whereas potential remains constant. This is most important. Then this is the trick that you have to use to identify either the resistance are connected in series or parallel. How to define? Now see here itself I will explain. See, the current is coming in this direction. Imagine at this junction, at this spot, current is changing its direction. It is moving in three different ways. So wherever the current changes its direction, it divides. That part is a parallel connection. That you make a note. Very important statement. What my statement is, in a circuit, wherever the current deviates its path, the current changes its direction, that is a parallel connection. If there is no change in the direction of the current, then that is series. That is series. Clear with the parallel circuit? Clear with the content? No doubt? Very good. Then note down. So, series and parallel, clear, no doubt. Now, I am going to merge both. In a circuit, as I said, there are many resistors and resistors are connected in both the types like series and parallel. So, let me draw one typical diagram. See here, it is like this. And in your board exam, that may be your CBSE, ICSE or the state, to calculate the total resistance in the circuit, you might have seen the diagram like this one. This is, I used to call it as a typical diagram. It is not a typical one. It is a typical diagram. Why I am telling this? It is having both series as well as parallel. That's the reason I used to call this type of images as a typical diagram for our current electricity. That is a combination of resistors. See here, this is the most important one. I am going to explain in detail how to check it. Now see here. If I name here R1, R2, R3, R4. And values I used to give like this. See, R1 as around 2 ohm, R2 and R3 sorry 7 ohm, R3 3 ohm, and R4 which number? Okay, 5 ohm, just for my reference. Just a number dear. There is no fix like this, any other number you may expect. Now see here. What is the total resistance across the terminal A, B? That's the question. I repeat one more time. In this circuit, what is the total resistance across the terminals A, B? Then how to do it? Very clear. Now see here. Imagine the current is coming in this direction. At this junction, current is dividing. Once again, current joins, current goes like this. That's it. ಅಂದ್ರೆ ಏನು ಅರ್ಥ ಮಾಡ್ಕೋತಾ ಇದ್ದೀರಾ? ಈ ಜಂಕ್ಷನ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಡಿವೈಡ್ ಆಗ್ತಾ ಇದೆ. ಎಲ್ಲೆಲ್ಲಿ ಕರೆಂಟ್ ಡಿವೈಡ್ ಆಗಿದೆಯೋ ಅಲ್ಲಿ ಪ್ಯಾರಲಲ್. ವೆರೆವರ್ ಯು ಕ್ಯಾನ್ ಸಿ ದ ಕರೆಂಟ್ ಇಸ್ ಚೇಂಜಿಂಗ್ ಇಟ್ಸ್ ಡೈರೆಕ್ಷನ್, ಕರೆಂಟ್ ಇಸ್ ಡಿವೈಡಿಂಗ್, ದಟ್ ಇಸ್ ಪ್ಯಾರಲಲ್ ಸರ್ಕ್ಯೂಟ್, ರೈಟ್? Then it is very clear. R2 and R3 are in parallel, whereas R1 with this with R4 is series. Pakka? Then how to clear? First clear this box. First clear this box, then add with those two. That's it. Okay, let me help you out. See here, Rp will be equal to here R2 R3 divided by R2 plus R3. How that? Then substitute the value. 7 into 3 divided by 7 plus 3. So 7 3s are 21, 7 plus 3 is 10. So here is 2.1 ohm. That's it. In a parallel voltage value, it is 2.1. Then total resistance. Total or resistance will be equal to R1 plus resistance connected in parallel plus R4. R1 resistance connected in parallel plus R4. How that? That's it. Now see here, R1 how much I have taken? 2 ohm. RP is 2.1 ohm plus R5 is 5 ohm. Then it is 5 plus 4, 9, 9.1 ohm. That's it. Very easy, isn't it? How that? So that's the reason I said this one is a typical diagram. Done? Please note down. Now see here. Don't panic. Don't panic. It's easy. I will teach how to solve it. See now. Here the question. What is the total resistance across the terminal AB in the circuit? What is the total resistance across the terminal in a AB? Now see here. Here also we will consider the direction in which the current is flowing. Imagine the current is coming in this direction. Okay. Now see, can you see this junction? In this junction, the current is dividing into 3 different paths. Now see here, first path, it will move without changing any direction. Means here, there is no change in the direction of current. Second path, it will move straight. And the third path, it will move and join at this direction and it will move. ಇದು ಟ್ರಿಕ್ ಇರೋದು ಹೌದಾ ಅಂದ್ರೆ ಏನು ಈ ಜಂಕ್ಷನ್ ಅಲ್ಲಿ 3 ಪಾತ್ ಡಿವೈಡ್ ಆಯ್ತು ಸೊ ಇಟ್ ಇಸ್ ಪ್ಯಾರಲಲ್ ಬಟ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್ there is no change in the direction of the current. Here there is no change in the direction of the current. ಹೌದಾ means first clear this part. Very much important. That's a trick. First clear this box. The rest it will be easy. See here. Let me use that dotted line. These 3 are in series. These 3 are in series. See here. Resistance connected in series will be 1 plus 1 plus 1. It is 3 ohm. Now see these 3. These 3 is also connected in series. So here also resistance connected in series. I will call it as RS1. RS1 will be equal to 2 plus 2 plus 2. It is 6 ohm. Now another one is there. Don't forget this one. This is also connected. How these 3 are connected? These 3 are connected in parallel. Which are those 3? RS with 2 ohm and RS1. These 3 are connected in parallel. Then how to calculate? I taught you this method. See here. 1 divided by RP is 1 by R1 plus 1 by R2 plus 1 by R3. Now see here. It is 1 divided by RS plus 1 by 2 ohm. 1 divided by RS1. For your reference, I had written in exam. These things are not required to write. Directly you substitute and solve the solution. Now see here. 1 divided by 3 RS plus 1 by 2. This one plus 1 by 6. How that? Now what is the LCM of 2, 3 and 6? 6 is the LCM. So 3 table 2s are, 2 table 3s are, 6 table 1s are. So 3 plus 2, 5 plus 1, 6. So it is 6 by 6. It is 1 ohm. So resistance connected in parallel is 1 ohm. Andre ಏನರ್ಥ ಇಲ್ಲಿ ಏನು ಬಾಕ್ಸ್ ಕಾಣ್ತಾ ಇದೆಯಲ್ಲ ನಿಮಗೆ ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಫ್ರೇಮ್ ಒಳಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕನೆಕ್ಟ್ ಆಗಿದೆ ಅದರ ಟೋಟಲ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ 1 ಓಮ್ ಮುಗಿದೋಯ್ತು ಕತೆ ನಾವು ಸಿ ಹಿಯರ್ ವಾಟ್ ಇಸ್ ದ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ will be equal to 1 plus 1 plus 1. That's it. It is 1 plus 1 plus 1. It is 3 ohm. Then you may ask the question, sir, how sir 1 plus 1 plus 1? Very simple. First resistance value is 1. This box total value is 1 ohm, and this is 1 ohm. 1 plus this junction plus this, all three are connected in series. Then sum is 3 ohm. Move. 3 marks question. It carries 3 marks. Isn't it easy? Here, the trick you should follow only one thing, that is, if the current is dividing, that is parallel. Keep that one in your mind. In other words, if current is not dividing, it is series. Current divides, parallel. Current is not dividing, that is series. Kelkatam nadapan. That's it. Then substitute to this one, you will get a solution. Pakana, very good. Please note this one, important diagram. Okay. Yes. Now students, the last important one numerical that I am going to teach, then we can wind up this session. Now see, what the question says. See, the resistance are connected like this. Okay, let me write here. A and B. And the values of resistance are like this: 8 ohm, 4 ohm, 5 ohm and X. Calculate the value of the X if the total resistance of the circuit is 4 ohm. The total resistance is 4 ohm anta ide, and ee circuit alli ಎಷ್ಟು resistance ಇದೆ? ಈ circuit alli 4 ohm ಅಷ್ಟು resistance ಇದೆ. Then they calculate the value of X. X na value ಏನು? That's it. Now see here. Why I have selected here? It is having both series and parallel in a different way. That's the reason I have selected this question. Now once again we will follow the same thing. Our current is here. It is coming like this. It's this junction. Current is dividing into 2, and here there is no change in the direction of current. It joins and it moves. Andre artha ಮಾಡ್ಕೊಳ್ಳಿ, current divide ಆಗ್ತಿರೋದು ಈ junction ಅಲ್ಲಿ. Means this set and this set are in parallel, but these two are in series. Okay, then how to calculate? See here, first let me take R1 is 8 plus 4. It is 8 plus 4 is 12 ohm. That is R1. Now go to the R2. R2 is 5 plus X ohm. That's it. 5 plus X. Now what we have to calculate? We have to calculate the value of X. X na value ಕಂಡುಹಿಡಿಯಬೇಕಲ್ವಾ? How these R1 and R2 are connected? R1 and R2 are connected in parallel. Then how to use the formula? I taught you very clearly. RP will be equal to R1 R2 divided by R1 plus R2. Isn't it? Howdalla? Now just substitute the value. RP value is given as 4 ohm. 4 is equal to R1 is 12 into R2 is 5 plus X whole divided by R1 is 12, R2 is 5 plus X. Then clear? Now see here, it is 4 is equal to 12 of 5 plus X divided by 12 plus 5 is 17, 17 plus X. See here, 4 ones are 4 threes are. Then what is remaining? This one will go here. So 17 plus X will be equal to 5 threes are 15 plus 3X. Now transpose. So 17 minus 15 is 3X minus X. 17 minus 15 is 2. 2 is equal to 3X minus X is 2X. 2 get cancelled. The value of X is 1 ohm. That's it. So what's the value of X? We have calculated. The value of X is 1 ohm. Now see here. I think after listening to this class, I hope the doubts what you are going to have with respect to resistance, resistivity or the combination of resistance is clear. Is that clear? Then in the next session, I am going to solve all the numerical what is going to present in your textbook. ICSE Grade 10 Physics Concise. What are the problem present in exercise 8B? All the numerical I am going to solve in the next session. Till now, take care. And one more request from myself, if you have not subscribed Sumanth tutorial, I request please subscribe. Till now, take care. Bye bye.